So this one is asking for area between the function and the axis. So do you know what to set up for this? We need to set up an integral expression to figure it out. So it would be the integral of what then? From where
Is
to
it
where?
from 4 on the top and 2 on the bottom?
Well, where's the area start? The shaded area start
At 1?
at 1, right? So it should be from 1 to 4.
Oh,
Do you know what goes in the integral?
the equation?
Yeah, the function. Okay, so then this integral expression will tell us the area between the curve and the axis. Do you know how to evaluate this integral?
The first one should like find the antiderivative or something.
Yeah, exactly. So the derivative of what gives you e to the x minus 1? You know what
Is
that
it
is?
is it just gonna be like e to the x minus 1 minus e to the x?
So it's close, yeah. So what's the derivative of e to the x?
I have to find it in my notes.
So remember, the derivative of e to the x is just itself. Does that make sense?
Yeah.
Right. So the antiderivative of e to the x is also itself. So in this case, there you can the antiderivative of e to the x minus 1 is just itself, right? And you can check by taking the derivative. The derivative of e to the x minus 1 is just itself. And the x minus 1 part is an inner function, but the inner derivative of x minus 1 is just 1. So antiderivative of e to the x minus 1 is just itself, e to the x minus 1.
What about the minus e?
Okay, so minus e, so this is a number, right? A constant. Let me ask you this then. What's the derivative of something like 3x?
Hold on. I'm thinking. Just 3.
3, yeah. The derivative of 3x is just 3, right? So what's the antiderivative of 3?
3x.
Yeah, 3x. So this, if you go this way, this is derivative. If you go this way, it's the antiderivative. Does that make sense?
Yeah.
So notice that e is just a number, right? So then what's the antiderivative of e? Because e is pretty much like 3. It's just a number.
X?
E times x. Yeah. Does that make sense?
Yeah.
Okay. So then once you get the antiderivative, do you know what to do with this?
Now don't you have to plug in 4 and the 1 then?
Yeah. How do you plug it in?
In the x's.
Right. So what do you get then?
Is it e to 4 minus 1 minus e times 4?
Okay. Four. Let's call that e cubed minus 4e. And then what else?
Then e to the 0 minus e.
Okay. And what do you do with these?
Wait, is it a 1 or an e?
Oh, sorry. E. Yeah. And what do you do with these?
And then you subtract them from one
Yeah.
another?
You subtract them.
Like, how do you do that?
You can just line it up like this. In this case, you just like see if you can combine the like terms. And so these ones are like terms. What's minus 4e minus a negative e going to be?
Or negative 3e?
Yeah, negative minus 3e. So then those combine. So then what are the terms that we have left?
So it's e to the 3rd minus 3e?
And then what else?
Oh, plus c?
We don't need the plus c because it's a definite integral. But what about this term here?
Oh,
Minus 1, right? Because there's a minus in front.
oh, yeah, minus 1.
Okay, yeah. So that's what this is the exact answer then. So yeah, whatever decimal you get out of this would be the area, this turquoise area here.
Okay.
All right. Okay,
Yeah.
what are the functions?
That one's y equals x squared minus 27. And then y equals 13 minus 3x. This is what you set them equal, right? Like we did before.
Yeah, let's just draw a quick picture. Do you know what the x squared minus 27 looks like?
Gonna be the u again.
And what's the minus 27 do?
It's like it lowers it.
Yeah, shifts it down. Okay. So we have a parabola that looks like this. And then what does the other function look like?
Gonna be a line.
Yeah, how is it oriented? What's the minus 3 tell you about the line?
That's the slope. Oh,
And
like it's going down, it's going
yeah,
down.
decreasing. Okay, and what's the 13 do?
Is that the intercept?
Yeah,
The
intercept, right? So it's shifted up. The intercept's up and it's going down, right? So
the-
it's got to look something like this. Okay, does that make sense?
yeah.
And then, right, in this case, I'm assuming it's asking the area between the curves. So we have to start here and then end here. These will be our bounds, the left and right bounds. Okay, so if you set it equal, what you get?
Oh, x squared plus 3x minus 40.
Okay,
Then you factor that, right?
yeah,
So it's x minus 5, x plus 8.
okay.
And so are those going to be like the numbers in the S thing?
Yeah, that's to your left. So what are these X values that you get?
X equals 5 and negative 8.
Yeah.
But then like which ones do you put on the top and the list goes on the bottom?
So it's bottom to top, left to right. So bottom goes with the left endpoint, top goes with the right endpoint. All right, so now we have to find the area between the curves. So then where do we start? Or just what number goes on top, what numbers goes on the bottom?
Is the 5 on top?
Yeah, 5's on top. It goes to 5, right? Because that's on the
Then-
right.
Okay, then negative 8's on because it's on the left.
Yeah. -8
Okay.
to 5. Right?
And then like do it like we did before, like we took the two of them and then we minus them.
Yeah.
You do that.
Remember, it's always top minus bottom. Because you're
Okay.
taking the top y values and subtracting the bottom y values, and the difference is the area.
Okay, so the 13 minus 3x minus the other one?
Yeah. Yeah, the lines on top for this area. What's what it look like? 13 minus 3x, and what else?
No, minus the x squared minus 27.
They're like this.
Yeah. Cool.
Well,
In parentheses.
yeah. Since you're subtracting multiple terms, you're subtracting the quantity of x squared minus 27. Okay. And
So
then
then,
dx.
then it totals negative x to the second
Okay.
minus is 3x plus 40.
Yeah, plus 40. Okay. Okay.
And then you find the antiderivative of that.
Yeah.
So it's negative x to the third over 3 minus 3 over 2 x squared plus the 40x.
Okay.
And then you plug in the 5 and the negative 8. For 5, I got 725 over 6.
Okay, 125 over 3. 625, 75 over 2. 200. Okay. Yeah. What'd you get for the 8? Minus 8, negative 8.
Negative 736 over 3.
Okay. 8 cubed, 64.
And minus that.
Yeah. Okay. This is going to be positive number. 364 times 8. It's 512. 12. Yeah. And then minus 64 times 3. 12. 192 minus 320. Okay, yeah, I'm just gonna use a calculator for this. What'd you get overall?
Decimal, like 366.2.
Okay. I'll just use the integral function. So negative 8. See, x negative x squared minus 3x plus 40. Okay, is it 366?
0.2.
Yeah, okay. This should be it.
Yeah, that's what I got.
Okay. Yeah, that should be it. That's the area between those curves. All right. Do you know what 8x looks like? Y equals 8x. Where's the intercept?
0, 0, right?
Yeah, 0, 0. Because the y-intercept is there's no plus b, which implies b is 0. So it goes through the origin. And then what does the 8 mean? Or what does it mean graphically in terms of the equation of the line? Yeah, slope. Yeah, so it's going to be a slope. Okay, roughly like this. All right, what about the x squared minus 9? What does that look like?
It's like a U, right?
Yeah, and what does the minus 9 do?
It moves it downwards.
Yeah, exactly. Okay. Okay, so yeah, so it looks like this. Okay, and then do you know what area we're trying to find? I guess we can just double check and see what these intersections are. So yes, let's set these equal to each other first. So then what do you get?
Oh, so it's x squared minus 8x minus 9. Then you factor it.
There, minus 8x minus 9. Yeah, equals 0. You can factor this. What do you get?
So you get x minus 9, x plus 1.
Okay. Okay. Yeah. So then what are the x values then?
Oh, so it's x equals 9 and x equals -1. But don't
Okay.
you don't use like the 9 because like it's not between the 2 points that they gave us?
So they want these to be the bounds, right? Is
Yeah.
that what the problem's saying? Okay. Okay. So it has to be starting from here somewhere. Okay, and then you have to set up. Okay, then it goes to 3. So that means that implies you to set up 2 integrals because you need to know this intersection because they switch. So we have to find these two areas, this area here.
So it's just between like the red lines
Yeah,
of like what the graph is.
yeah. So so this is what the picture is gonna look like. You have the
Like,
parabola and a
you don't
line.
go below, right?
So yeah, you start at negative. This red line is -5, and then this is 3. Does that make sense? And
Yeah.
then you're trying to find the area from between these two curves are bounded by all three of these curves, as well as this area here. Okay, does that make sense?
Yeah.
Okay, what do you set up then for these areas?
You're using like the S thing, right?
The integral of what?
So you do like the -1 and -5.
Yeah, do you know why you have to go from -5 to -1 instead of all the way to 3?
Isn't that that's like where they're intersecting in like the middle?
Yeah, why do you have to stop at the intersection? Yeah, the idea is that for calculating the area of the integrals, it's always the top function minus the bottom function.
Mm-hmm.
And notice that when it crosses, the top function and bottom function change, right?
Yeah.
Because for the green area, the top function is the parabola. But then once you get to the purple area, the top function becomes the line. So that's why you have to break it up into 2 integrals and then switch them because the top function is different for the 2 areas. Okay, so for the green integral, -5 to -1. So what do you plug in here?
Don't you have to do like the 8x like minus the x squared minus 9?
So you have to do top minus bottom. So if you look at the green area, which function's on top?
Oh, the x squared minus 9.
Yeah, so that comes first, and then what do you do? Then you
That's
can
minus
minus
8x.
8x. Yeah. Okay, so that takes care of the green area, and then the integral for the purple area. What do you get for that?
Oh, it's the 3 over the -1.
The 3. Yeah, it goes from -1 to 3, and then what do you plug in the integral?
Do you do the same thing? The x squared minus. Oh, no. You do the opposite, right?
Yeah, exactly.
So it's 8x minus the x squared minus 9.
Is it like this?
Yeah.
You have to be careful when you're subtracting.
That that's like add a 9.
Yeah, you have to distribute the negative. So you can either throw in parentheses, which makes it clear, or you can just distribute, but I think the parentheses makes it clear what's going on. Okay, yeah, and then that would be the area of the purple area there. Okay.
Mhm.
Okay,
Now
so
you
let
have
me
to find the antiderivatives of those equations.
yeah, for each of these. Okay, so what's the antiderivative of the first integral?
X to the third over 3,
Okay, yep.
and then 9x minus 4x squared.
Okay, yeah. And then what would you do with this?
Then you plug in the -1 and the 5.
Yeah.
So -1, 14 over 3. The -1 is.
Oh, actually, overall.
Oh yeah, that was -1. Then you're minusing by the -5 is
-1/3 plus 9. Okay, let's see. -125 over 3 plus 45. 25 minus 100. Okay. Yeah, I'm just double check this. So -1/3, it's going to be plus. That's going to be 124 thirds. So going to be 5.
I got a total of 304 over 3.
So this is going to be minus 55 plus 55. 60. What's 660 times 3 is 180. Yeah, 304 over 3. Okay, yeah, that should be it for that. Okay, and then what about the purple one?
So the antiderivative is the 4x squared minus the x to the third over 3 plus 9x.
Okay, where it is. X third, x squared, x cubed, plus 9x. Okay, what's next?
Then you plug in the 3 and the -1.
Okay,
For the 3, I got 54.
let's see. 36 minus 27 over 3 is 9 plus 27. Okay, what about the -1?
-14 over 3. Then you subtract that.
Minus 1/3. No, plus 1/3. Minus 9. Subtract, okay.
And then I got 176 over 3.
These cancel it out. 176 over 3. Let me see. So 36 plus 27 plus 23 is 59 minus 1/3, it looks like, which is equal to 60. 180, 177, 176 over 3.
Yeah.
Okay, yeah.
And then do you add or subtract those last two numbers?
You added them. Yeah, because
Yeah,
you're combining the areas, right?
Okay, so I got 160.
Okay. Yeah. 304 plus 176. Yeah, I think that works out nicely. It's 480 over 3, 160.